Usually quadratic equations are given in this particular form here. Y is equal to ax squared, in this case a is equal to 1, plus bx plus c. And when you look at, you could graph this, you probably know that it's a u-shaped function because the coefficient of the x squared is plus. But if I was to ask you what is the minimum point on this, what is the turning point in this function, you wouldn't know. Vertex form gives us this particular form. So let's have a look at it. So this is the function x squared plus 2x minus 3, and you can see by the graph that the minimum point is minus 1 minus 4. Well, the technique is called completing the square, and it works like this. Now, x plus 1 to be squared minus 1 minus 3. Now, where do all these numbers come from? Well, the x plus 1 comes from, first of all, it's an x because it's an x squared, so that's the x. The 1, this one here, comes from half of this number here. So I half the 2 and I get 1. I then square this all together. My minus 3 is still here. The reason there's an extra minus 1 in is because when I do x plus 1 to be squared, that gives me x squared plus 2x plus 1. I want the x squared plus 2x because that's in my function. But I don't want this extra 1 that squaring has given me. So I take it away. So this function here that you're looking at is exactly the same as this up here. I've rewritten it in vertex form. So that's going to be x plus 1 to be squared minus 4. That is in vertex form. Now, the reason it's called vertex form is that we minimize or maximize this function if this here to be squared is 0. And we make this 0 by making x equal to minus 1. So this function here is at its minimum value when x is equal to minus 1. And when x is equal to minus 1, then y is equal to minus 4. So our minimum value is equal to minus 1 comma minus 4. And as you can see, that's over here. Okay, let's have a look at another one. The question might be, can you find the minimum or the turning point of this function here? F of x is equal to x squared plus 8x plus 7. So let's proceed like we did the last time. I'm going to do x plus 4 to be squared. The 4, because comes from its half of 8. I then have to subtract 16, because when I square x plus 4 to be squared, I get an extra plus 16 that I don't want. And then I write down my original plus 7. So it's x plus 4 to be squared minus 9. So the minimum point on this function is equal to minus 4 comma minus 9. All right. What happens when the coefficient of the x squared is greater than 1? So let's have a look at this one. We'll say 2x squared plus 6x plus 3. Can you work out the minimum point on that? We'll say y is equal to. Now what I need to do is, I need to take out a 2, x squared plus 3x plus 3 over 2. Look what's happened here. I want it in x form, x squared plus x plus a constant form. So I factor out the 2. So I just ignore the 2 for the moment, it's factored out. And now I continue on doing my completing the square like I did before. So it's going to be 2, open bracket, x plus 3 over 2 to be squared, because half of 3 is equal to 3 over 2 to be squared. I need to subtract a 9 over 4. This 9 over 4 is 3 over 2 to be squared, which is the extra bit that I don't want. When I square this, I'm going to get x squared plus 3x plus 9 over 4. So there I am subtracting it now, minus 9 over 4. And here's my plus 3 over 2. That's all multiplied by 2. So it's going to give me 2 into x plus 3 over 2 to be squared. And then minus 9 over 4 plus 6 over 4 is minus 3 over 4. You can do this on a calculator. I like to do it in fractions. Minus 9 over 4. This here is 6 over 4. So plus 6 minus 9 is minus 3 over 4. Now I multiply my 2 back in, and I'm going to get 2 times x plus 3 over 2 to be squared minus 3 over 2. So, again, my vertex point on this is still going to be minimized or maximized, depending whether it's minimum or maximum turn, whether it's like this or this. But it's going to be minus 3 over 2, comma, minus 3 over 2. So that's the minimum point on this particular function. And here's a copy of the graph, 2x squared plus 6x minus 3, which is 2x squared plus 6x plus 3, 2x squared plus 6x plus 3 here. And there's your function with the minimum point, minus 1.5, minus 1.5. So it works, and it's not too difficult. One more thing, let's do another example. And this time we'll do a minus 1. So we do minus 3x squared plus 7x plus 8. Okay, you factor out the 3, so that's going to give me minus 3 into x squared minus 7 over 3 x minus 8 over 3. Okay, be careful of the signs here, because when you're factoring out the minus 3, that becomes minus 3x squared plus 7 over 3x plus 7x and plus 8 as well. So now we continue on as we did before. We're going to give minus 3 bracket x minus 7 over 6 squared. And I'm going to give myself a minus 49 over 36 minus 8 over 3. Okay, the minus here becomes from 7 over 6 to be squared is 49 over 36. So continuing on, I get 3 open bracket x minus 7 over 6 to be squared. Now you do this in your calculator, minus 49 over 36 minus 8 over 3. And that equals minus 145 over 36. I then complete by multiplying in by the minus 3. So minus 3 into x minus 7 over 6 to be squared plus 145 over 12. The 3 will, when the 3 on the top will actually minimize this 36 down to 12. Okay, now this is a n-shaped function, so the maximum point is equal to 7 over 6, because I need to make this bit here 0, comma 145 over 12. And that's completing the square and vertex form. And finally, just a moment, I want to explain something briefly, is why do you make this x minus 2 in order to get your minimum point? And why do you make the x plus 2 to get the maximum point? If we just forget this as being x plus 2p squared and just make it, for example, p squared. If the p is 0, well then, if the p is 0, so 0 squared, well then this particular value here is going to be the smallest value in this function. Any other value for p, and we're going to have, say, 1 squared plus 7, that's 8. So, in other words, we've gone higher than 7. Or if p was minus 3, well, minus 3 to be squared is going to be plus 9. Again, that's going to be 16. So again, 7 is the minimum. So, but if p is 0, we get our minimum point. So in order to make p or 0, we make the x equal to minus 2. Equally over here, we've got a maximum value. Imagine here now we just don't think about it as being x minus 2 to be squared. Just think of it as being minus p squared. Now, if p is equal to 0, we're not subtracting anything from the overall function. If p is equal to 1, we're going to be subtracting minus 1 squared, which is minus 1, and that's minus 4, that's minus 5, which is not a maximum point. Minus 5 is lower than minus 4. Or if p was minus 6, then minus 6 to be squared is plus 36, and that's minus 36. It's always going to be negative. Minus p to be squared is always going to be negative, which means you're going to be making this function smaller than minus 4. So minus 4 is the maximum value in this function. That's just a bit of background on that. Okay, hope that helps. Thank you.